Friends, welcome to my YouTube channel. Dhanesh here. See, today we are going to discuss the most important and the most fundamental concept in statistics. It's really important for machine learning. Standard deviation. So what is standard deviation? This standard deviation and another concept. See, you can see the video in the playlist. It is variance. We have already this video in the playlist. You can watch that. Standard deviation and variance both are somewhat similar concepts. Then you may think why we are coming up with these two different concepts. I will explain that as well. See, both these concepts are used to understand how the data is spread across. See how the data is, if you understand, see, when I talk about variance, I told, see, variance, it's a measure of the spread between numbers in a data set. In the same way, standard deviation is also the measure of spread between numbers or between data points in a data set. That is standard deviation. So in statistics, as I told, the standard deviation is a measure of the amount of variation or dispersion of a set of values. That is standard deviation. You understood. If you want more clarity, I can tell you, see, I am giving the marks, of, the students in a class. See the marks, it's given like 40 out of 50. The marks are out of 50. It is 40, 41, 42, again 40, 41, 42, like this. For 10 students it's there. Here if you see this data, the variation is less, the spread is less. It is, the average, the different values, the different marks in this data set is close to the average or mean value. Here the standard deviation or variance, we can tell it as less. See, to understand more clarity on variance, you please that the separate video for variance, it's given in the playlist. I will be giving the link in the description as well. You please watch. All these are all very important concepts from a machine learning perspective. See, that's what I told, how much it is vary, but I am giving the marks out of 50. Again, it is in another class, the marks are 22. It is out of 50. Again 30, 40 and 49 and 17. So here the marks, it's all these marks are out of 50 out of 50. These marks, the different marks are, it is not close to the mean value. The variation is very high here. The data is spread across, in the spread is more. So you can, if you see the bell curve, if you draw the curve for this, if this spread is very high, the curve will come like this. If the spread is less, you will get a curve like this. The spread is less, the bell curve. That's what we use. This is the distribution of the data. So you understood. So both this variance and standard deviation denote how much. It is a measure of the amount of variation or dispersion of a set of values. Now I will come to the more details, in-depth mathematics and the formulas of this standard deviation. It is it is calculated as the square of the variance. See, standard deviation we define mathematically. It is defined as the square of the variance. Square of the variance. Standard deviation is denoted by the letter sigma, and it is the square of the variance. Really sorry. It is the square root of the variance. Really sorry. It is the square root square root of the variance. So standard deviation is the square root of the variance. See, for a variance we have discussed the formula. You can see that video separately. Variance is denoted by the letter, we call it as sigma square. So the formula for variance, it was sigma I is equal to 1 to n xi minus x bar the whole square, the whole divided by n. So this was the formula, it is given. All right, so this is for variance. So standard deviation is the square root of the variance, means this is the formula for standard deviation. So xi, x bar and n we defined there as well. I am again telling you xi is the value of the ith point in the data set, value of the ith point in the data set, that is xi. Then what is x bar? X bar, the mean value of the data set. X bar is the mean value of the data set, that is x bar. Then what is n? N is the number of points in the data set. We have told you n is the number of points in the data set. N, number of points in the data set. So you understood what exactly is the formula here. You can easily understand. See, if you want to calculate, see, xi minus x bar, if you want to understand more clearly how you will apply it in the formula. For example, you have some again I am taking the example of marks. Out of 50 we have marks like 40, 42, 43, 20, 21, 30, like this. So what is the average? That is, we call it as the x bar. Yes, x bar. So what is the average? You will x bar, you will calculate. It is 40 plus 42 plus 43 plus 20 plus 21 plus 30, the whole divided by 6. So that you will get it as the x bar. So that is the x bar. So this is the xi. Now you will calculate xi minus x bar. So how do you calculate this? From this average, for the first one it is 40 minus this average x bar. Here 42 minus x bar. Here 43 minus x bar. Here 20 minus x bar. Like this you can calculate. In the next table you will calculate in the next table you can calculate xi minus x bar the whole square. Xi minus x bar the whole square you can calculate. You will get values like this. Here you will calculate the sigma, the summation. Sigma means this is the capital sigma. In Greek you have the small sigma and capital sigma. This sigma you may be familiar. This denotes the summation, sigma. Integration is also a type of summation. Fine. So sigma, this is the capital sigma. So you will add all these, then you will get the sigma xi minus x bar the whole square. Then you will divide with n. N means 1, 2, 3, 4, 5, 6. Here n is equal to 6. Then you will add 6, then divide with n. Then you will take the square root. This is the way you calculate it. So this is the standard deviation. You understood how you are going to calculate it as well. So standard deviation is very useful tool in investing and trading strategies, and it helps measure market and security volatility and to predict performance trends as well. So we are using it in investing and trading strategies. Standard deviation, it is a very important parameter in statistics. Another important point you need to understand is if the data values are all close together, the variance will be smaller. Since the variance represents a squared result, it may not be meaningfully expressed on the graph as of the original data set. So hence, we are using standard deviation as a solution. See, variance we usually define it as the square. The formula for variance. It's a really important aspect. Variance we have defined it as sigma I is equal to 1 to n. This is the formula, xi minus x bar the whole square, the whole divided by n. So the root of this is standard deviation. So when we square it, we won't get the exact result for the data because it's a squared value. That is the drawback of variance. To rectify that, we are coming up with the concept of standard deviation. Standard deviations are usually easier to picture and apply because it gives the exact result. We are taking the square root, then we are getting the exact value. The standard deviation is expressed in the same unit of measurement as the data, but that is not the case with variance. Variance, it is you are taking the square and then you are getting, so it is the square of the values. The biggest drawback of using standard, that is the advantage of advantage of standard deviation. Now the drawback of standard deviation. Even when we discussed about variance, I told you the advantage of variance and the drawback of variance as well. And now here I told the drawback of variance. See, here also the biggest drawback of using standard deviation is that it can be impacted by outliers and extreme values. That is the drawback. And one more thing you need to understand, there are two types of standard deviations. One is the population standard deviation and the sample standard deviation. So we have population and sample. We have a separate video on that. You please watch that. So population is there and sample is there. You please understand these terminologies. These are all really important. See, the population standard deviation is used when an entire population can be measured and is the square root of the variance. So the population standard deviation, I am first defining the population standard deviation here. It is sigma is equal to root of 1 by n sigma. This sigma and this sigma is summation. Sigma I is equal to 1 to n, 1 to capital N, because here we took capital N. So 1 to capital N xi minus mu the whole square. This is mu. Mu is another Greek letter. I will write it correctly. You will understand that this is mu. Mu the whole square. So this is for the population. Here mu is the mean. See, mu denotes the mean. But when you consider the sample standard deviation, you will take the mean as x bar. So in the previous formulas, I was using mu. Now the sample standard deviation, in many cases it is not possible to, why we are defining sample standard deviation means, in many cases it's not possible to sample every member within a population. Then we will come up with the sample standard deviation, and it is denoted by the letter S, and the formula is little bit difference is there. 1 by n minus 1, the root of 1 by n minus 1 sigma I is equal to 1 to n xi minus x bar. You need to understand here x bar is the mean of the sample. See here, what is n? This n is the total number of the population. It is the population number of the population. Here we are taking a sample, and what is the n here? It is the sample size, not the population size here. Very important. It is the sample size. It is not the population size here, this n. And what is x bar? X bar is the sample mean. It is not the population mean here. Here mu is the population mean, and one difference is there. Here it is n minus 1 and here it is n. So there are two types of standard deviations you can define. One is the sample standard deviation and another one is the population standard deviation. So that's all about standard deviation. It defines how much the data is there is how much it is a measure. I can tell you standard deviation is a measure of the amount of variation or dispersion of a set of values, how much the data is spread across, and it is how much it is varying from the mean or average. Both variation and standard deviation gives the same concept. It represents the same concept, but what is the difference, where you will go for standard deviation, where you will go for variance. We discussed this, and you need to understand what is the advantage of standard deviation and what is the disadvantage of standard deviation. Because when we apply these concepts to the data sets, all these concepts you need to understand. So what is the advantage of standard deviation, disadvantage we discussed, variance also the same thing we discussed. See, I will be coming up with more videos. We have finished many aspects: deep learning, machine learning, math, statistics, supervised machine learning, many algorithms we finished. Please subscribe my channel. Thanks for watching.